Hey, let's look at the substitution rule again. Well, the point is we have done the substitution rule for indefinite integrals. Now we want to use it also for definite integrals. And in fact, to go from one to the other is really very simple. It just requires a little bit more of bookkeeping as we did before. So let's look here on the left. Here's the indefinite integral, 3x squared square root of x cubed plus 1. So this means we need to find the antiderivative of this term. Using substitution, right, we introduced a new function u. So in this case, u would be x cubed plus 1. And then we needed to transform the differential. So we write du is the derivative of the right-hand side, 3x squared. And the plus 1 differentiated is equal to 0, dx. And then we saw already that this 3x squared dx appears in the integration. So we can write integral 3x squared square root of x cubed plus 1 dx is really the integral of square root of u, and then the 3x squared dx is equal to du. So we need to integrate u to the 1/2, and the integral is u to the 3/2. But then we need to get the factor right, so there must be a 2/3 in front. And then we get a constant because we are looking for a general antiderivative. And then the final step would be to substitute what u is. So u was x cubed plus 1 to the 3/2 plus a constant, and we are done. So now let's look at the definite integral here, where we integrate the same function, but between -1 and 1. And again, we would like to use substitution. So I introduce again the same u. U is x cubed plus 1. I do the same transformation with the differential. Du is 3x squared dx. Then I'm already in a position to transform the inner part of the integral. Now what is missing now is the boundaries, right? We integrate from -1 to 1, which we need to transform to u now. So this is new. So when x is -1, this means u is what? Well, sub it into the formula. -1 cubed is still -1 plus 1, so that would be 0. And if x is the upper boundary, 1, then u would be 1 plus 1 is 2. So the new integration boundaries are 0 and 2. So then we continue. Integral -1 to 1, 3x squared root of x cubed plus 1 dx. This then is equal integral from 0 to 2, and then square root of u du. Okay, so what I indicated in red here has changed compared to the other case on the other side. But now we can continue. We need to find the antiderivative of square root of u, which is u to the 3/2 times a factor 2/3, u to the 3/2. But then instead of writing plus c, now we have a definite integral, so we go from 0 to 2. Which meaning we need to sub in 2 and we need to sub in 0. If we sub in 2, then we get 2/3. We can do as 2 to the 3rd, which is 8. So that would be like a square root of 8. If we sub in 0, we get a 0. And now square root of 8 we can write a little bit nicer. This is 2 times square root of 2. And then the 2 multiplies with the other 2, so we get 4/3 square root of 2. So instead of getting a general antiderivative like here on the left, now we get a number. We just get a number, and as you know, this corresponds to the area between the curve and the x-axis. The difference here is that we transform the boundary conditions too. So let's look how this looks formally. Here it is written formally, so we need to assume g prime is continuous on an interval ab, and f is continuous in g, and then we can write the integral a to b f of g of x, g prime of x dx equals the integral of g of a and g of b, f of u du. Again, we transformed the integral boundaries as well. Hey, let's just do one more example. So solve the integral from 1 to e, sine of log x divided by x. Of course, using the substitution rule. So we substitute u to be log x. I think that's a good candidate here. And then the derivative du by dx is 1 over x. So we write du is 1 over x dx. You see this 1 over x dx appears right here in the integration. But we also need to transform the boundaries. So if x is 1, then this means u is ln 1. But what is the logarithm of 1? Well, ln 1 is 0. Right? E to the 0 is 1, so this is 0. If x is equal to e, then u is log e, and the log of e is equal to 1. Again, when I say log, I mean the natural logarithm, as you clearly see in my writing. So then we can transform the integration. So then instead from 1 to e, now the 1 corresponds to the 0, and the e corresponds to 1. And then we get sine of u, and then this 1 over x dx is in fact du. Oh my goodness! Do you see how this simplified? We just need to integrate the sine, which of course is minus cosine. So we get minus cos u between 0 and 1, which is minus cos 1, minus minus, which is plus, cos 0. Cosine of 0 is 1, so then this is 1 minus cos of 1. Hey, that didn't look so easy. Hey, that didn't look so complicated. Let me summarize. So we learned 2 substitution rules, one for indefinite integrals and one for definite integrals. They really work the same. You define this function u and then need to find the inner derivative. In the second case, for the definite integrals, you also need to transform the integral boundaries. Hey Tolo. Tolo, you know, for the virus infection, you need to wear a face mask. Do you have a face mask? Well, Tolo, you need to cover your nose as well.